Hello students, welcome to Swapna physics classes. In this lecture I am going to explain you one more important short answer question for your TS first year intermediate IPE physics examination. And the question is, state parallelogram law of vectors, derive an expression for the magnitude and direction of the resultant vector. Okay, for this purpose I am considering two vectors, vector A bar and vector B bar. I am taking two vectors which are starting from a single point O. Now what I am doing, I am drawing a parallel line to the vector A and also a parallel line to the vector B. If you observe carefully this image, the shape of this image is a parallelogram. The shape of the image is a parallelogram. I will draw neatly. I am taking a parallel line to the B vector and a parallel line to the A vector. The shape of the image is a parallelogram. Okay, this is the shape of the parallelogram, and for parallelogram the two opposite sides are equal in magnitude and will also have same direction. For a parallelogram, the two opposite sides will have same direction and are equal in magnitude Therefore you can represent this vector with A bar, and you can also represent this vector with B bar. These two are opposite sides and these two are opposite sides, and angle between these two vectors is theta. I am taking the angle between these two vectors as theta, and if this is the diagonal of a parallelogram, this is point A, P, Q. Okay, now coming to the statement. If two vectors represents the two adjacents of a parallelogram, these are the two vectors which are the adjacent sides of a parallelogram drawn from a single point, then the resultant vector, this is the resultant vector, okay, is the vector sum which is represented by the diagonal of a parallelogram drawn from the same point. The resultant vector will also start from the same point and it will be the diagonal of the parallelogram. This is the resultant vector. I am taking it as R bar, okay, and this will be equal to vector sum of these two vectors, that is A bar plus B bar, according to the statement of parallelogram law of vectors. If the two vectors are the adjacent sides of a parallelogram which are starting from a single point, then the diagonal of this parallelogram represent the resultant of the two vectors, and this will be equal to vector sum of these two vectors. Okay, we will derive the resultant of the magnitude of the resultant of the vectors as well as the direction of the resultant of the two vectors. Okay, and for this purpose let us extend the line OP. Let us extend the line OP and draw a perpendicular line from point S, and I am taking this point as N. Okay, and the angle theta is in this direction, therefore we will have theta in the same direction, not here. We will have theta here. Okay, I am erasing this statement. And from this diagram, this is a right angle triangle, right? ONS is a right angle triangle. This is the right angled triangle. And using Pythagoras theorem, by using Pythagoras theorem, what is the Pythagoras theorem? Hypotenuse square, that is OS square, from angle ONS, okay, OS square is equal to ON square plus NS square from Pythagoras theorem, right? Now this OS square, what is OS square? It is R square, which is equal to, what is ON? ON is nothing but OP plus PN. OP plus PN, we have square, whole square here, plus NS square, okay. This R square is equal to, what is OP? We have vector A bar, okay, and the magnitude is A. Magnitude of this vector A bar is A, okay, plus Pn, we don't know, Pn whole square plus Ns square. We have to find out this value of Pn and Ns, okay. Now to find out this, what I am doing, I am considering the triangle SPN. From triangle SPN, what is cos theta? We have cos theta is equal to base by hypotenuse. Cos theta is base by hypotenuse from trigonometry. What is the base? Here we have Pn. And what is hypotenuse here? PS. This is the right angle triangle S and P. For this triangle we have PS as the hypotenuse, right? And now cos theta is equal to, what is Pn? We don't know Pn, by PS. What is PS? It is the magnitude of the vector B bar, right? Now this Pn is equal to B cos theta. This is equation number A. Okay, this is equation number 1. This is equation number A. Copy this. And from the same triangle SPN, what is sin theta? Sin theta is opposite by hypotenuse. Okay, what we have here opposite to this angle? SN or NS by hypotenuse is B. Okay, therefore NS is equal to B sin theta. This is equation number B. Okay, what we have? Pn value B cos theta and Ns is B sin theta. Now substitute equations A and B in equation 1. Okay, R square is equal to A plus, what is Pn? We have, what is Pn? It is equal to B cos theta whole square plus, what is Ns? It is B sin theta. We have square here, therefore B square sin square theta. Now the resultant vector R square is equal to, this is in the form of A plus B whole square. What is A plus B whole square? A square plus B square plus 2AB, right? So we have this R square is equal to A square plus B square cos square theta plus 2 into AB, that is A into B cos theta. plus b square sin square theta. So if you observe carefully here, you can take b square common. Therefore, r square is equal to a square plus b square into sin square theta plus cos square theta plus 2ab cos theta. And what is the value of sin square theta plus cos square theta? It will be equal to 1. It is equal to 1 from trigonometry. And now this r square is equal to a square plus, if you substitute 1 in place of sin square theta plus cos square theta, you will have b square into 1 plus 2ab cos theta. This is the resultant vector. Okay, this r is equal to, if you bring this square on right hand side, or if you apply square root on both sides, this r will be equal to square root of a square plus b square plus 2ab cos theta. 2ab cos theta. And if the vectors a and b are parallel to each other, if the vectors a and b are parallel to each other, what happens? Theta will be equal to 0. The angle between these two vectors will be equal to 0. And what is cos 0? Cos 0 is equal to 1. Okay, if a vector is parallel to b vector, then the angle between these two vectors will be equal to 0. Then the resultant r is equal to square root of a square plus b square plus 2ab into 1. What is cos 0? Cos 0 is equal to 1, right? Therefore the resultant vector r is equal to, if you observe carefully these values, that is a square plus b square plus 2ab will be equal to a plus b whole square, right? What is a plus b whole square? A square plus b square plus 2ab, right? So square root of a plus b whole square, r will be equal to square root of a plus b whole square, and square root cancel. Therefore the resultant vector r is equal to a plus b. Resultant vector. Okay, I'm taking the magnitude only. This is case 1. If that value of theta is equal to 90 degrees, if you substitute in this equation, cos 90 is equal to 0. Therefore you will have r is equal to square root of a square plus b square only. This term becomes 0. 2ab cos theta will be equal to 0. Okay, this is the magnitude. This is the magnitude of the resultant vector. I had given the statement for the parallelogram law of vectors and derived the magnitude of the resultant vector, and now we have to derive the direction. We have to derive the expression for the direction of the resultant vector. Take the screenshot. Just pause the video and take the screenshot. Now how to find out the expression for direction of the resultant vector. Direction of the resultant vector. For this purpose, what I'm doing is, let this vector r bar makes an angle alpha with the vector a bar. This angle alpha gives you the direction for this resultant vector. First of all, we will find out the value of alpha, then I will explain how this angle gives you the direction of this resultant vector. Okay, And for this purpose, let us consider the angle SON. SON, okay. From angle SON, what is tan alpha we have? Tan alpha is opposite by base. What is tan theta we have? Tan theta is opposite by base. Opposite to this angle is NS, and what we have the base? Base is ON. This is equals, what is NS we have? B sin theta by what is ON? ON is OP plus PN, right? Now this tan alpha value is equal to B sin theta by what is OP? It is equal to the magnitude of the vector A bar plus what is ON we have? B cos theta. From this, alpha is equal to tan inverse of B sin theta by A plus B cos theta. Okay. Depending on the angles theta and alpha, depending on the angle theta, the angle alpha varies. Okay. And if the angle between this resultant vector and the vector A decreases, this will be the direction of the resultant vector. As it keeps on increasing, the direction changes. The direction of the resultant vector changes. Okay. So this angle alpha gives you the direction of the resultant vector. And one more point is, what is the resultant vector we have? R is equals magnitude of the resultant vector is square root of a square plus b square plus 2ab cos theta. Okay. The magnitude of the resultant vector depends on the vector A, magnitude of the vector A, magnitude of the vector B, and also the angle made by the vectors A and B, the angles between A and B. Okay. Here the direction depends on the angle between these two vectors and also on the vectors A and B. Okay. And here I will end our lecture. And whoever didn't subscribe to my channel, please subscribe to my channel and click on the like button, and also please share with maximum number of people possible. Okay. Bye.